We are asked to draw the Newman projection formulae for the compounds ethane, ethanol, N-butane, cis-hexene and trans-hexene. We represent ethane in such a way we are able to see two carbon-hydrogen bonds in the plane of paper, two carbon-hydrogen bonds going behind the plane of the paper, and two other carbon-hydrogen bonds projecting towards the viewer in front of the plane of the paper. We look through the front carbon so that we are able to draw the Newman projection formula with only one carbon visible. The other carbon gets exactly behind the front carbon. We do not see the rear carbon, we see only the front carbon. So we have drawn the structures of the eclipsed and the staggered. In staggered, we are able to see all the 6 carbon-hydrogen bonds, 3 of the front and 3 of the rear. In the eclipsed form, we will view only 3 carbon-hydrogen bonds which are in front. The other 3 carbon-hydrogen bonds exactly get behind the front arrangement. It is called eclipse because each carbon-hydrogen bond of the front carbon would eclipse the carbon-hydrogen bond of the rear system. So following this, we will be able to draw the staggered and eclipsed form of ethanol. We have shown only the staggered form. There is another possibility. We can write the eclipsed. In the eclipsed form, the OH goes exactly behind a hydrogen. The eclipsed form can become the staggered form, or the staggered can become eclipsed by rotating the rear carbon by 60 degrees. When I turn 60 degrees or rotate 60 degrees, we will be able to convert one to the other. In N-butane, we will be able to draw two staggered structures, one called the anti and the other called the skew or gauge. In skew or gauge, which is a staggered form, the two carbon methyl bonds are at an angle of 60 degrees. But in the anti form, we find the two methyl groups are diagonally opposite, but both are staggered in the sense we are able to have view of the 3 carbon hydrogen bonds of the front and the 3 bonds of the rear. In the eclipse, we have two arrangements where a methyl can be eclipsed by a methyl or a methyl can be eclipsed by a hydrogen. We have cis 3-hexene and a trans 3-hexene. We are writing the alkene in such a way. We have carbon-carbon double bond, two groups projecting in front of the paper and two groups going behind the plane of the paper. We look through one carbon in such a way the two carbons all are in the same line. This way we are able to write the Newman projections for the cis and the trans forms. In this case, we have only two groups attached to each of the carbons, unlike in the previous case where we have each carbon carrying 3. Now the third position can be taken like an orbital of each carbon. The pi bond can be shown to occupy the third position, which prevents a free rotation. So in this case, there is no free rotation possible as in the case of ethane or ethanol or N-butane. Whereas we can convert eclipsed ethane to staggered ethane by a simple rotation about the carbon-carbon bond, we cannot convert the cis form to trans form by a rotation because there is restricted rotation about the carbon-carbon double bond.